Technology is the practical application of scientific knowledge or inventions in order to solve everyday problems and facilitate human activities. As a matter of fact, the products of science contributed immensely to the development of the Western nations and the Asian tigers because professionals in those climes were able to invent machines and equipment used in industries, hospitals, agriculture, automobiles, aircraft, and so on. All these were achieved through homegrown technology, not imported technology. And that's exactly the thinking of those who created and established the National Agency for Science and Engineering Infrastructure, NASENI, the agency that has the capacity to entrench homegrown technology, as you may have observed in our previous editions of NASENI Milestones. In today's package of the program, we will take you to the oldest NASENI Research Institute, the Scientific Equipment Development Institute, SEDI, in Enugu. This is where a whole lot of scientific and technological activities take place. The institute has excelled in the production of science teaching equipment, glasswares, machine spare parts for industries, as well as agro-based machinery. There are more to appreciate of SEDI Enugu, including advanced manufacturing. Now let's take you there. Today we begin our tour of SEDI Enugu with a stop at the Electric Laboratory, a section of the Electric Research and Development Department, where teaching and learning equipment are manufactured. Uzo Henry Nemeka is our guide.
Here we display some of the teaching equipment produced here in SEDI. One of them is this. This is the basic machine trainer. This is a trainer that helps students in the tertiary institution to understand the behavior of electric machines, especially the electric motor. They need to understand the effects of voltage variation on this machine. This can be understood with these digital displays you have here, the voltage, the currents of the motor. They would need to understand the behavior of this motor and how these characteristics varies depending on the parameter you changed. Here we also have our electronic bench sheets. This bench sheet is where an electrical engineer or electronic engineer can do all the practice that he wants to do. He can run various experiments because it has a variable AC and variable DC, where you can actually get whatever voltage you need and also perform all kinds of experiments, being sure that a circuit breaker there can always help to take care of whatever short circuit or any problem that the circuit may have, especially because it's designed for students who can make some mistakes, so that when there's such things happen, the breaker, which is the protective device, can help to handle the situation. Here we have the power electronics trainer kit. The power electronics trainer kit is what the students use to study the behavior of solid-state devices in the control, processing, and conversion of electrical power. It doesn't matter where you are. You can have your AC. You want to take it to DC. That is power conversion. You have your DC, you can want to take it to DC. You have it. That means it has an AC to AC converter. It has AC to DC converter, DC to DC converter, and also AC to DC converter. This is because the power we have in our house, especially what we use in our television, you have your AC coming into the building, but that is not actually what the television needs to work with. They need to understand how to take this AC to a DC, and that means rectification. They need to rectify these alternating currents to get a direct current supply, which the appliance needs at that point. Also, the DC to DC, also you can also find, you want to have a DC already, but then you want to take it up to a level, a higher level, or you want to take it below what you have as your source. This also let them understand what and what you need to put in place to have this power converted to what you actually need.
At Scientific Equipment Development Institute, Enugu, science equipment for teaching basic sciences are produced. These equipment can also be referred to as demonstration equipment, which are inevitable in science class teaching environment. Let's now meet Dr. Ephraim Ozihu, Head of Material and Equipment Testing Laboratory.
All the equipments, science equipments we use at basic levels are produced in SEDI Enugu. And most of them are used for demonstration work. But this is a little stand to demonstrate what? Pendulum experiments. We have for chemistry, burette stand. This is what? For biology equipment. Cut section of what? Leaf. Dicot roots, leaf. We have the eye models. We have the stop clock. We have test tube and test tube rack for practical experiments in chemistry. We also have what we call the root system. The root system is produced here also in SEDI Enugu. We used to teach about what? To teach transport system in plants. We also have different types of beakers and glasswares. And these glasswares and beakers are produced in SEDI Enugu. When you go around, you see them. Most of them are used at basic levels to teach sciences at basic level and also post-primary school systems, like in secondary school. During examination and WAEC, this lab is designed to carry out all the experiments required by what? WAEC examination. That's an improvement. Therefore, we extend our services to natural sciences. My right-hand side, you see different types of microscope. Meteorological microscope, binocular microscope, monocular microscope, centrifuge. Then, distillation equipments. We also see electrophoresis machine here. We also have analytical weighing balance. These equipments are for natural sciences. We move from basic sciences to natural sciences. In our universities, at 300 levels, all the equipment we have here can accommodate them. They come here for research work. This one is what? Viscometer, used to measure viscosity of a liquid. I've told you before, this one is for DNA test. We have sensitive weighing balance. We have magnetic stirrer. We have a setup for distillation method, a simple distillation method. Most of the secondary schools, this lab contains both chemistry, physics, and biology, extended to geography, at which all the equipment we have here can be accommodated or used in teaching science subjects. And because of that, we have some of measuring equipments, something like Richter stand, we have measuring cylinders, we have voltmeters, we have ammeters, we have potentiometer. They are the product of SEDI Enugu. Then we have what we call meter bridge. We have meter bridge here. We have meter bridge. We have ammeters, as I told you. We have stop clock. In engineering, we have engineering testing equipment. Different types of engineering testing equipment. This one is called compression testing equipment. It is used to test strength of bricks. For example, the bricks you have here, you check for the strength of the bricks. The compression testing equipment will give you the strength and also analyze it and plot the graph. We also have the one we call universal testing machine. This one does compression, it does tensile test, bending and flexural test. This one is what? A multi-purpose type of what? Testing equipment. It contains all the testing equipment in one unit. This is produced in SEDI Enugu. This demo is called total internal combustion engine, reciprocating tap. It is used to teach the strokes of internal combustion engines, how fuel is burned in the carburetor. We have the inlet stroke, we have the compression, we have the power and the exhaust. Two of them are internal combustion engines.
The optical section of SEDI Enugu is where lenses and other allied products are made. Let's join Mr. Belongu Okechukwu and his team.
We produce what we call biconvex lens, biconcave lens, plano-convex lens, concave convex lens, triangular prisms, rectangular prisms, telescope, periscope. These are the product of optical section of Scientific Equipment Development Institute. And the production is not far-fetched. We have glass as one of our raw materials. We have another powder we call silicon carbide as our material. We have what we call Xerox powder for polishing. So with this, the production is in chain. We cannot do without the other one. This is a mirror with dimension 10 cm by 7 cm or 100 mm by 70 mm. That's what we do. So they are now edging the mirror so that it will not cut somebody's hand. That is what they are doing. Now, like I was saying, the production is not perfect. These are the machines. With this now, it's manual and labor intensive. So with this, we can now produce all these products that you are seeing here. This one is what we call biconvex lens, placed into the handle. So this one magnifies 3 times. We have this one as another convex lens, but this one magnifies 8 times. We have what we call concave convex lens. This is concave convex lens. This is another concave convex lens. Then we have this one as plano convex. Plano in the sense that a side is flat, while the other side projected outward. Then we have what we call rectangular prisms. They are of different kinds. And with these rectangular prisms, they are used in physics departments for physics experiments. Then we have another one called triangular prism. This is triangular prism. And we have this mirror that I have explained placed at the base. So with this, there is for physics experiments. Then this is what we call telescope. Telescope, we can use it to see something that is very far. It will draw it closer to you, and you'll be able to identify the object. And we call this one periscope. At times, periscope is used in submarine. And with this periscope, you can see something above your head. Then you can see something, if you slant it, you can see something by the side. That is periscope. It is not a lens, but a mirror placed at an angle of 45 degrees and in oval shape. This is periscope. Like I said, look at the production now. If we want to produce ×3 magnifier, we have it 10 mm thickness of glass, cut to dimension, place it like this on this mushroom. Then when we place it like this, what we do is to grind. By the time we grind, we get something like this. This is the grinding. As the thing is grinding, because of the nature of the carp and the mushroom, it determines the focal length. The curvature of the lens determines the focal length. So we can now grind it by the time we finish, we come to this point. This is the end. When we grind, fine grind or pre-polish, then we polish. Then after polishing, then we can now wash with alcohol. And after washing, then you will have something like this as the end product. So this is what we produce. Then the same thing applies to other lenses. Even the rectangular prism, triangular prism, we cut to dimension, put it in our disc, grind with what we call silicon carbide in this machine. Then when we grind, then we get it to a point, then we do the pre-polishing there. This one is cutting, we call it circular disc cutting machine. We use it to cut the glass that is so broad, so big, that we cannot even cut from with the diamond cutter. We are ready to work. And if all things being equal, this place sky will be our limit.
Up ahead is the glass blowing workshop, and that's where glasswares are manufactured. Here we have Enwaruzo Emmanuel and Emmanuel Obum.
What we do here is we try to fabricate laboratory glasswares. All the glasswares used in the lab we can make them, we can repair them, we can maintain them. That is our threefold production here. Then all those glasswares are made from glass tube. We don't make glass per se, but we use glass tube to fabricate all those things. We make test tube, we make condensers, we make all types of flasks, we make all types of beakers, all the rods, all the glasswares you can see in the lab. We can produce them here using the simple glass tube, which comes in two different types, the hard glass and the soft glass. The hard glass is called borosilicate, the soft is called soda lime. This tube comes in so many diameters, from 5 mm to 100 mm. Then once you cut the tube, then you cannot put it to shape and shape it to whatever you want to do. And that's how we can make our tester funnel, we can make our centrifuge tube, we can make our gas dryers, or otherwise called U-tube with arm. We can make the measuring pipettes. Also, the condensers. Also, we make here the condensers using the same glass tube to make it. We can make a variety of, even the water filter pump for organic filtrations. This one is used for organic filtration. It is called water filter pump. All these things are what we can produce here. Then down to the display kits to display raw materials. All these are our products. Even the droppers. You can see at times you may need to drop a little liquid into experiment. Then all the droppers, we can make them here. Even the laminar tube loss. You can see it is small but very important to calculate the losses in a tube. That's what this one is normally used for. Even the coil condensers, the coils, you can see all these are condensers, are coils made of glass used to make the condensers that can distill even alcohol. And that's why they are used here. Also, we make the water level apparatus. This shows you that water takes is level. You can see the tools are different, and water can always be in the same spot with all of them. Then the water level apparatus. All these things are what we make. Using here also, we use gases to work. We use butane gas, oxygen gas, and compressed air. The mixture of the gases now will now melt the glass for you. And once it is melted, you now can blow it to shape. You can join it, you can cut it, you can put it to shape. And once those things are done, you've gotten what you want, what you need by glass. Then you can put it to shape, blow it into a U-tube, blow it into a bulb. You can join it. You can even make it into rods. You can see all these are rods put together to make a chromatography of it. Then these are some of the products. You can see the biometric flask. So for students in Kierian, so these are part of our products and the things we do here. You can see anything glass, we can make it. Anything glass you think.
As you can see, this is part of my products, my research work. So we produce it here. Now this very one, this is what they call in international standard. They call it early condenser. This is what we call spiral condensers. It's a component part of spiral condensers. We also develop it here. There's equipment we use to develop this very well. Now this clavenger. This is a clavenger apparatus. It's for analysis. That is for essential oil, to extract essential oil. That is the function of this clavenger. Then this is a water distiller. Also produced here. Then this is special equipment that they use both in the hospital and chemistry lab. It's called suction machines. We use it to evacuate some of the body fluids, especially when the doctor is carrying out operations in the hospital.
Now you have seen the amazing works of Nigerian engineers and scientists at the Scientific Equipment Development Institute, SEDI. One major objective of this program is to inform Nigerians about the skills and capacities of our scientists and engineers and the imperativeness of the National Agency for Science and Engineering Infrastructure, NASENI, in entrenching homegrown technology in Nigeria as the only sure way of becoming a true great nation. NASENI personnel across the country have demonstrated competencies in various aspects of science, technology, and innovation. And what is required of us to do as a nation is to leverage on that and expand its horizon for sustainable industrialization. There is no shortcut to technological advancement. You have to walk it, as NASENI is doing. We challenge the private sector, especially the rich, to embrace local efforts at producing local technology. Here now is the Executive Vice Chairman of NASENI, Engineer Professor Mohammed Haruna, and the Acting Managing Director of SEDI, Engineer David Daniel.
Scientific Equipment Development Institute, MINA, and Scientific Equipment Development Institute, Enugu, are among the first generations and part the oldest of NASENI's institute. The mono mandates of both Enugu and MINA is in the area of development of science laboratory equipment to help demystify sciences, the teachings of basic sciences. We commence with doing production of primary school science equipment, things that our pupils are familiar in their environment, the natural environment, not to bring stories and books of the kind of science product that are in Europe. What is the sciences behind butterfly, between those things children are playing with at home? What can they do with bamboo? What is the biological analysis of things they apply? Talking about the sound, the clapping of hands, to develop local equipment to make it easier and interesting. How about a lantern? What can make it quench? What can make the luminous in intensity or brightness? What can they do for it to work? All those things that are familiar local terrain. What are the sciences to develop interest in science? Then the success of that and the support of many organizations like initially African Union or OAU at that time, then UNESCO has made it possible, and then with the coming of universal basic education, to make all this equipment available across the country. There is no state or local government in the country that has not received this in Nigeria. We advance and produce genuine science equipment for secondary school learning, junior secondary school in particular. The products we make 100% with local content, cover all the practicals needed as contained in their curriculum. I move further to do that of senior secondary school. And with our partnership with De Lorenzo of Italy, feedback system of UK, SENAI of Brazil, we now produce science technical laboratory, not only for skill acquisition, but for tertiary institutions, the universities, the polytechnics, the colleges of education in all areas. And then got involved our mono mandate institution to be producing some component on their areas of competence and specialization for the two scientific equipment institutions to do that, and continuously upgrading our equipment, modernizing, and then using the reality. Now we saw the need to develop online practicals, virtual practicals during the COVID-19, and today these are used by many schools, television houses. The good thing about our scientific equipment is that you can do practical anywhere, mobile laboratories. People can carry his handbag home, which contain all the kits he needs. He can do practical at home. He can do homework. There is battery, even if they don't have electricity. Dry cells provide energy for at their own level, and to a higher level at tertiary institution, we attach with solar module, solar panel, that you can generate electricity anywhere and be able to apply, because this is compulsory. One of the reasons why we have failure and dwindling quality in our products from tertiary institution is what we garbage in from primary school to secondary school. And we are challenged because we used to come across workers that they have excellent results, but the equipment they are supposed to be master on it, they have never seen it practically.
All the things that we use in this country, even in the schools, in the labs, in the institute, in the industries, we are supposed to be developing them and then seeding the technologies for those institutes to begin to function. So you can see that we are almost at the backbone of all of these systems. So that is who we are. When we say seed the technology, that's the real final way you can really say whether we're succeeding or not. You develop, you need to seed. But I found out along the line that for the Nigerian market, for you to seed the technologies, they will not pick it the way we are looking at it. So in my view, I've tried to look at a different approach to trying to seed our technologies. The approach is simply take down all the things that we have, break them down into their component parts, develop the technology in those different component parts, then seed those component part technology. Then the people now produce those things, bring them back, and then have an assembly part. Then you begin to have a complete product being completed, and then you're pushing into the market. Just for instance, if you look at the motor vehicle part is made up of different parts, and it's not one person that you who's making a vehicle. Yours is just the design. You have your concept, you have everything, but the bulbs are somewhere else, the windscreen is somewhere else, every other thing, but you have your concept, you have your brand, you bring it in, then you sell. The same thing for us. And the essence is that once we now take all those products, break them down, we will continue with our own R&D works. If we continue the R&D works, we will also feed those SMEs with our new innovation so that they too can also up their skills. Because we are also not trying to feed into the Nigerian market. We want to feed into the African market and beyond. That's where the whole market is. So, but if your products are not competitive, you cannot be. So the essence of all this, the R&D work we continue, we feed our SMEs, they too now feed the products, and then their products are competitive. Then we now have at the back of people bringing in the different product to make up the final product that has an end use. Because the thing is this, once the people find that there's a market, they will come into it. And then for the Nigerian market, the way it is, most people don't like to start it at the beginning. But to follow up, I mean, Nigerians are very good copiers. But once the thing takes on, you find the whole thing. So for us, we must see that technologies. And we've been able to identify at least 6 of them that we need to break down, begin to pass those parts into different things, and then have technology that we can seed.
That's our package for today. Thank you for watching, and do tune in again next week as we continue to be in the vanguard of homegrown technology. I am Kierian Umeayo. Bye for now.